All right. Welcome everyone to our last talk of the day, where we will be learning about integrating Jython with Java. So please give a warm welcome to Jim Baker and Shashank Bharadwaj.
So before I start, how many of you have been using Jython before getting into this? Okay, so fair number of people. How many of you have used Java in the past? How many of you, that's much better. How many of you have been working with Java in the past? Which language do you like better? Python? Java? There's always someone. So I think one of the informal mottos of the Jython project is we write Java so you don't have to. Any event. So I'd first like to, since this is the only Jython talk that's being held this year, just a little bit of what's new in Jython. First of all, we just released beta 1 of 2.7. Thanks. So it's only been delayed a bit, but any event, yeah, so hopefully we'll be getting that out later this year, depending, of course, on the bugs that are submitted, the standard process of moving to a final release. I can't wait till that gets out. I can't wait till we can finally start working on Jython 3x, for that matter. We'll be talking a little bit about what that could imply in just a little bit. We'll be sprinting on Jython 2.7 for that final release during the sprints, so please join us if you're interested. Why Jython? A lot of you have mentioned that you've used it in the past. Very compliant implementation of Python. Jython 2.5, of course, tracks C, Python 2.5. 2.7 tracks, I'm sorry, Jython 2.7 tracks C, Python 2.7. So that's the logic of our versioning scheme. In general, why Jython? The Java ecosystem is huge and growing, and the size is even beneficial. I mean, yes, there is a lot of cruft out there in the Java ecosystem, but there's a lot of good stuff, possibly at your company, that you need to integrate with, and you would still like to write Python code, because everyone here, except for one troublemaker, said they preferred Python, and I agree with that. We even prefer it in the Jython project. I'll show you what I mean by that in a moment. Pick a domain, there's likely to be a library for it. It could be machine learning, it could be the Hadoop ecosystem, whatever. Interestingly enough, because of the compliance that we see in Jython right now, you typically don't see users of Jython really saying, we use Jython. They say, we use Python, and that's great. You just have to simply install the Jython runtime support, and you see that with Sickly, you see that with Pig, you see that with some other tools out there. And again, some of them are quite good. Why not Jython? We don't have the C extension API, C types, Cython, etc. Unfortunately, that's growing increasingly important in, say, the numerical computing space. That doesn't mean we could not address it, it just simply means we don't have it right now. It's certainly possible. Like just mentioned that in terms of integrating Java and Python, there are other integrations. So we have something like JEP, which embeds the CPython runtime within the JVM using JNI. And actually there's JPipe, which goes the flip side of that. It embeds the JVM within CPython using JNI. Two different alternatives. You could bridge between CPython and Java using some form of IPC, and this is, I'm sure, very common. You may be doing that right now. Or you can even use IPC between CPython and Jython. So for example, there is this pretty cool tool called ExecNet, and there's some other tools just like this. I just happen to like this one. And it uses a very efficient sub-process communication mechanism between Jython and CPython. And in this particular case, it is simply going and setting up a sub-process of Jython, communicating with that through a channel, getting results. So you can use, in this case, I took this example straight from the documentation. And of course, if you're looking at it, it's like, why would I use Java util vector? Isn't that the most old school tool or API we wouldn't use anymore because of locking issues and so forth? But nonetheless, it's there. Integrations are, however, very shallow. Issues around callbacks, being able to extend Java classes in Python, et cetera, all the things that are actually really easy to do from Jython. So again, with Jython, we have this high degree of compatibility, the reg test to prove it. I don't know if this has ever bitten anyone, so this is a great time to ask. Have you ever written crummy code? No, wait a second. Have you ever written code that depends on the finalization semantics of the garbage collector in Python? That is that you're depending on this reference going out of scope to ensure that it is closed. Now, I believe PyPy has the same exact issue. So the question is, did that make any sense? What I just asked. And so, have you written that code? All right, makes sense? Written that code? All right, some people say yes. It is an important issue. The use of the whiff statement is the key to preventing that as a problem. That one usage, you're going to be writing better code that's not depending on things going out of scope, which may inadvertently not go out of scope to get something closed. And it will be compatible with PyPy, it will be compatible with Jython. Of course, Jython has no global interpreter lock. Sometimes I like to demonstrate what would happen if you tried to go. We have this from future import the GIL. Of course, we have a little Easter egg to say never is going to happen. Well, actually, we've been thinking about adding the GIL, so that's not quite true. But it would be just in order to support the C extension API. So it's not just a joke that I was making. There are some reasons to doing something like that, but it wouldn't impact code that did not depend on a C extension API GIL. I don't know how that's going to be reported on Twitter. Okay, so just think, no GIL, never a GIL. And threading is currently efficient, unlike some of the examples that were presented yesterday with the PyPy STM. That's a great technology, but of course, if you're looking at threading right now, it works really well. Moving on. I won't even have time to get into this, okay. So, to a large extent in this talk, I'm going to try to do some sort of metacircular approach where one thing that we like to do in the Jython project is we like to use Python as much as possible. In our tests, we test it that way. In our libraries, we obviously like to write our libraries using Python. And I'm going to be using some of those in presentation because I think those show off the level of Java integration that is available. And the Model C Python, same thing. Tests and libraries use Python too. But again, not to the extent that we necessarily do, because we can reach back into the Jython runtime itself and get at what's going on there in terms of its public API, just as you would be able to from Java. Lastly on this, in terms of one of the reasons I'm bringing up these tests is because they cover a lot of corner cases. So you may have, what would happen if I had something like this? I would actually say, go look at what we've done here. You would find some useful source code in there to think about what's going on with Jython. Okay. Little typo. And the only thing that this ever comes into a problem is that because these are not true unit tests, they are relying on the existence of a suitable amount of the runtime and language being available. It does present some problems for us in terms of refactoring, but I don't think it really matters for you guys. Okay. So in terms of the use of Java from Jython, Python code can directly import Java classes as if they were Python classes. And I think this is how they know Jython. So it should not be too different from what you've seen in the past. You can construct Java objects from Java classes as if they were Python classes or Python types. You can work with Java objects. Your programs call Java methods or have Java called back into Python, again, as if it were just Python. And this integration, the reason it works at all is because we have built a proxy on the fly for you, bridging the difference between Java and what it looks like in Python in your code when you're calling Java from Jython. And you get something like this. So this is a classic example of code you don't want to think about having to write something like Apache POI, which allows you to read and write Microsoft Office documents. So, a good example of why you would want to do this is if you're looking at some vast trove of docs and you want to go and say, hey, I have all these Excel spreadsheets. I want to bring them into, some new system. This is an opportunity to do so. You can use Apache POI to go and read the spreadsheet. And look what you're doing here. You are able to go and import those Java classes as well as Python. So I have context lib built into the standard library. And I'm able to use standard constructs like the with statement. So I'm depending on the fact that I'm running in Jython 2.7, so I don't even have to say from future import with statement. I'm able to say with closing file input stream. That is coming straight out of Java. As well as closing HSSF workbook. That's coming straight out of POI. And be able to go through each of the sheets in the spreadsheet, the rows and cells and so on and so forth. And you have a classic loop, nested loop that you're doing there. But you're doing it in the context of Python, so you're able to go and interpret what's going on there in order to do some interesting work. So the scaffolding is really straightforward. The ability for you to do some interesting complex computation, you know what you got to do. It's going to be very straightforward if you have an idea of what problem you're trying to solve. So one of the things with respect to this is I would like to just point out some of the type equivalents here. And I just went and pulled this out from a chapter on Java and Jython integration from a book that I co-authored that's available at jythonbook.com. And there's a long chapter on this very topic. But the important thing to know is that there is quite a good equivalence between Java and Python. But we are doing some steps along the way to make that happen. So we use these following methods. We use toJava, we use Java to PY, usually used transparently. But sometimes there's significant overhead because of boxing and unboxing. That's one thing to consider in your code. So there are alternatives to doing that. And there are also some implications for how this boxing and unboxing works. The one thing I would want to point out about this, however, is even though this boxing and unboxing occurs in the actual function calls, it doesn't necessarily actually happen due to inlining by the JVM. Most JVMs inline very well, and we will be able to actually see better inlining in the future with stuff like the invoke dynamic support that Shashank, for example, has worked on once we get that in. So again, it's a common idiom to do boxing and unboxing, and therefore, as a common idiom that causes a lot of inefficiency without this sort of support, the JVM actually does a very good job in optimizing it away. Okay. I mentioned toJava here because you may be an example where you've written some library and you want to go and have this nice transparency between what's happening on the Python side and in the Java side. An example of this is what was implemented in datetime. And you can see it here. We have toJava is the method that you need to define for this particular type. It goes and uses this ridiculous class from Java, one of the worst classes in the standard library, unfortunately, for Java. The author of this freely admits he made a serious mistake in terms of making the types, datetime support, mutable, and you can see it right there. What is this? Calendar clear? Calendar set? No. It should have been in the constructor all along. Yeah, Josh Block would definitely talk about that as being a problem there. Okay. But I'm not going to pick on him. One thing that you would also want to consider with respect to Java that we're just seeing is that the choice of the method that is invoked on your behalf, if the method is overloaded in its signature, there's a fairly complex algorithm, which I'm not going to detail here right now, which selects which one. If it chooses wrong, you need to go and ensure that it picks the right one. As it says, sometimes the runtime picks wrong. Force it by using constructors like these in order to ensure that you get the right selection, or some other constructor on those arguments of that particular method. Another integration that you can choose is JSR 223. It's been part of the release since 2.51, although, to be honest, 2.52 was really when it became really usable. It's intentionally shallow, but we have seen it to be very popular with integrations like tools like Mule ESB comes to mind. And that's because it can be quite effective at driving Jython at the top level. So I just made the transition from talking about calling Java from Jython to now calling Python code from Java. Should have had a transition slide, but that's what's going on here. This is sort of like what we'd expect in a good script, this sort of top level, you are just calling this thing, it's encapsulated, there's not necessarily a lot of interaction going on. And so this would be an example of how you could use this code. And this is actually just coming from the script engine test that's part of our JSR 223 testing. You can even test JSR 223 support from Jython itself. And I thought this was super clever when I wrote this. It's like, this is the right way to do it. Why do I want to go and write, I know it's a little bit, it's not so much more noise, but I felt this was just the right way, and I have access to generators there, or I'm sorry, comprehensions, and I'm able to go and just write some very compact code to go and test this thing out. I was like, this is great. I'm loving it. If I'm saying something like that, you know that there's a problem. So, it's all this is good, but not without issues as we found in our usage. I love this earlier. I'm loving some snide comment I wrote earlier about 5 years ago or whatever it was, 4 years ago. Earlier version of this test also tested so-and-so and so forth. Unfortunately, it introduced an action at a distance where aspects of the sys-state change, which then impacted this other test. For now, there may be limits in how much we can test Jython from itself, no matter how attractive from an Ouroboros perspective, that is the snake swallowing the snake. That may be, the snake swallowing its tail. Certainly worth revisiting in 2.6. Clearly, I did not, or someone did not update that since then. But anyway, I just found this test earlier today when I was thinking about this. I think we need to let you talk, right? Okay. So there's an example of doing something very similar from Groovy, which is kind of interesting in terms of being able to take advantage of this from some other language. And I am just going to, if we have time, we'll move back to some of these interesting topics, but let's go and let Shashank speak about gradual typing.
Okay. So yeah, for the next couple of minutes, So I want to take you to the land of programming languages, where just for the next couple of slides, forget about Jython and Python, okay? But let's think about, we're looking at Jython and Python and how to integrate these two. And there's a good aside on how to do this in programming languages. Gradual typing was a new type system introduced by Jeremy Seek and Walid Taha researchers and extended by various others. And what this does is it's a new type system which provides seamless integration between statically typed languages, statically typed part of the code of a language, and dynamically typed part of the code. What they originally introduced was they introduced the dynamic type in a static language. So there was a statically typed language, they introduced this dynamic type. And the good part about this is it also provides this guarantee that if the statically typed part of your language is type checks correctly, then you will not have type errors at runtime. So we thought we could use this nice property of gradual typing and get it into Python. So with that, we wrote a small Python module for Python, which can run on Python 3x. This makes use of the different type annotations that was introduced in 3x, so the function annotations and class decorators and function decorators. And what it basically provides is sort of type checking, and I have an example over here. So it provides type checking for your code, and you can now have statically typed parts of Python code which are statically typed, and this can be checked at runtime so that you don't have to do this checking for yourself. So here's an example. So all you have to do is...
And I should point out, this is just vanilla Python 3x. No modification to the underlying runtime at all.
Right. So all you have to do is, let's say you have your awesome API that you want to expose to the outside world. But you know this API can be abused in various ways. So what usually happens and what developers usually end up doing is they have a bunch of checks to make sure to sanitize their inputs, to make sure that the input is of the correct type. But it would be easier if the API just specified a particular structural type, which can be easily done in Python using metaclasses and stuff. So here's a very simple dumbed-down example. So you have this from gradual import typed, and in your API, you would just annotate your API with @typed. And then all your API, you would use function annotations to say that the inputs have to be ints, and the return type has to be int. So the answer to life, A and B have to be int, and the return type of that function has to be int. So once you say that, the use of the API and the use API function can pretty much do whatever it wants, but if the input, so a print of x.answer to life, 10 and 32 would print out 42, as you would expect. But if you pass something like hello in there, so which is a string, now it throws, the gradual module itself throws an error saying, hey, I expected an int, but got a string. So this is very useful because the developer now does not have to go and drill down to your library code and fetch and figure out that they passed the wrong input. Now they directly know that they had to pass an int instead. And this works beautifully if you want to document your stuff as well. So this is a good documentation.
And of course, what we see with this is you may think, types in Java, obviously statically typed, that's what we expect of Java code. But we want to be able to marry these things together. And here we have.
Right. So just before that, you can go get it at, you would just pep install it and get this module. And we're still working on sort of accurate representations of objects and working on blame tracking. Okay, so yeah, about the Java integration as well. This is a very good candidate for Java integration because it's statically typed Python code. So now we have access to statically typed Python code. We can remove all the wrappers and object factories that were required to export Python code into Java and generate sort of plain old Java code, and that can be directly imported in your Java modules. So it reduces the proxies involved, and this could enable optimizations in Jython itself, because now we know the type of what you're declaring, so we know if it's an int, we don't have to create this whole big space for it and enable optimizations for you. With that, if you have any questions.
So, hi. I have actually one comment and one question. In one of your slides, you have shown project called GEPP, and I would like to bring to your attention or to attention of the audience one library called JCC, which is a very nice library for wrapping Python libraries or Java libraries. You can, using JCC, it's spelled like Java CC, you can include inside your Python code any Java library, and you can do the same thing the opposite direction. It's used by PyLucene project, which is a port of a Lucene search engine library. And if you would like to see an example of how we do it from Lucene to include Python code, you can search in Google for something called Monty Solar. And so my question is, these C extensions API, it's in making for long time, maybe 2 years, and everybody says it's going to happen, it's going to happen. So when is it going to happen in the end?
Well, I think the thing is that we've been discussing the possibility of a C extension API for some time. Prior to that, we were discussing the possibility of a C-type support, and there was some very preliminary implementation of that was actually brought in. Perhaps it should not actually be in the actual code base, but regardless, it's in there right now as an experimental feature. I can tell you that C-type stuff does not seem to be, I don't see that going anywhere, because we just found that was too difficult. The observation that we had looking at what was done with Iron Python was that the implementation of a C extension API was actually not that difficult, and we could imagine sketching that out against the JNI. It is simply just work that needs to be done, but we haven't had those resources or anyone who's actually spent that time on it.
But then this would then bring me to the idea, maybe you should look inside JCC, because there that implementer is called NDivida. He already did that. So maybe you should consider looking into that library.
I'll definitely, if there is support in JCC for the C extension API, that would definitely be, we love code wherever it comes from. One of the reasons that Jython has seen as much progress as it has is that we share code with projects like Groovy, like JRuby, on essential infrastructure. And so JLine comes to mind as something that we threw out our original readline, cruft, and brought in JLine, which has been standardized across many projects. We also went and did the same thing in terms of POSIX support with JRuby. The GSR 223 support is something that we share with Groovy. So definitely, I appreciate any code suggestions along those lines. So that sounds great. Thanks.
Okay, thanks.